Okay, everybody, welcome today. I have here a question on the screen that I want you to think about. The question is, what is 0 over 0? And I have here 5 potential answers. Is it 0? Is it 1? Is it infinity? Is it undefined? Does it depend on the situation? Those are the 5 choices. I'm going to put this up as a poll in a second, if I can get that working properly. So take a minute, though, to write down, do you think it's A, B, C, D, or E? And I am getting better at this. Okay, so there's the poll. Okay, 3 more people to vote. Okay, so almost everyone voted. And what we see, I don't know if did you get to see the poll results? Or do I just have to tell you them? You don't see it, okay. So nobody said 0. 1 person said 1. Nobody said infinity. 11 people said undefined. And 4 people said it depends. Well, we're going to see throughout this lesson that the most accurate answer is going to be E, it depends, because depending on the situation, I could get answers. I could get choice A. I could get 0 to be the answer, or 1 to be the answer, or infinity to be the answer, undefined to be the answer. Actually, I can't get undefined to be the answer. Oh, I suppose I could, yes. And I could even get other numbers, basically any number that there is could become an answer to this question. So it is going to be, it depends, and you'll see why as the lesson progresses. So all the, in the last lesson, the limits were usually, limit as x goes to infinity. Although there were a few where x was going like towards some kind of asymptote. But in today's lesson, we're going to see examples. I wonder why that would not open this file. I don't like it saying that. Okay, so here is an example of a limit, and I fixed up my font so that this is where the x arrow 0 goes. I know that on the last lesson I had it kind of like in between the lim and the function, but it really goes underneath like that. Okay, now if you plug 0 in, well, you get 0 over 0. So that's the whole point of this lesson. Is it a 0 over 0? Like 0 over 0 on its own doesn't have a specific answer, but the limit as x approaches 0 of some kind of fraction where both the numerator and the denominator approach 0, well, that can have an answer. And one way to visualize this one is to look at a graph. This is a graph of 0 over x for different values of x. So for instance, when x is 10, 0 over 10 is 0. This green line is the quotient. And when x is 9, 0 over 9 is 0, and so on and so on. Now at 0 itself, it's undefined. So there's like an open circle there. But when x is negative 5, 0 over negative 5 is 0 again. So this line, this horizontal line, even though there's no point at 0, it's got like a hole there, it's still true that the limit of 0 over x as x approaches 0 is 0. Because whether you're coming from the left or from the right, the y value seems like it's going to be 0, because as you get closer and closer to that undefined point, the function value is still 0. So this is an example where the answer would be 0. Oh, good question. Zachary asks, should I put a plus or a minus there? Well, in this case, we don't need to put either of them because it's the same answer. But if it had different answers, we would put a plus or a minus. Now, you might say, well, I don't know if it has, maybe I don't know that it has the same answer when I make the question. When you could still ask with a plus 0 with a little plus there, or 0 with a minus there. But if I didn't have the plus or the minus, and this was a question where from the left and the right, there were different answers, if that was the case, then we would say undefined. So in this case, we say the limit as x approaches 0. If I say a minus or a plus, there is an answer. But if I just say 0, I have to look at both sides. And if they're different, if the limit's different from both sides, we would say undefined. So we actually can get an answer of undefined. Okay, so what I've shown you here is that it is possible to get choice A. But that doesn't mean the answer is always choice A. Take a look at this question. Here's another situation where if I actually plug 0 in for all the x's, I'd get 0 over 0. But this time, anyone have a suspect? Actually, I could put up the same poll. Let me try something out here. Okay, I'm going to put a poll up here and ask you, for this limit of x approaches 0 of x over x, what do you think the answer is to this one? Okay, 5 more people need to weigh in. We got 13 results in. Okay, now I have 16 out of 18, which is what I got last month. So the results of this poll were 1 person said 0, 9 people said 1, nobody said infinity, 4 people said undefined, and 2 people said something else. So let's take, I'm interested in this. Can I, let's see, I don't want to show my whole desktop. Can I, let me try this. Okay, I hope, in the chat, are you seeing Desmos now? Desmos window, good. So for this one, here's the picture. So my function is x over x. And look at what happens. So when x is 5, I get 5 over 5, which is 1. When x is 4, I get 4 over 4 equals 1. And the green line is what it's becoming. Now notice that at 0 itself, there's a hole there. So it's not defined at 0, but for everything else, it becomes 1. And that's why the answer to this question, the 9 people who said 1 were correct. This is a situation where the 0 over 0 limit was 1. Okay, so we've seen a situation where the answer equals 0. And now we've seen an example where the limit equals 1. Now I'll tell you a few things now just so you can, if you have a 0 over a variable, the answer is going to be 0. For this one over here, if you were to reduce the fraction and the limit of a constant function is just going to be whatever the value is. So that would become 1 also. And here's a picture of that one. Okay, now here is another situation. Limit of 2x over x. Again, if you plug 0 in, you get 0 over 0. Let's take a look. I'm going to put a poll up and see. I really like this. Relaunch poll 7. Continue. Okay, so this was limit of 2x over x. And now you have the choices. Okay, 11 votes in, 13 votes are in. $15 votes, 16. Who are those other 2 people who aren't voting? Well, I'm going to call 16 all we're going to get. Oh, Chelsea, you can't see the poll. Okay. Do you want to write down into the chat what your guess is then? Okay. And in this poll, one person said 0, 2 people said 1, 1 person said infinity, 2 said undefined, and 10 said something else. Well, and Chelsea said 2, which is part of the something else. Well, Chelsea and those other 10 people are correct. It was something else. It was, oh, look at this, share results. Okay, so now you can see them. Stop sharing. Back to this. Okay, so let's look at this visually. If I change my function, actually I can't do that for this one. But I do have a picture for this one, so let me go this way. So where's that iPad? There it is. Okay, first of all, look at the picture. So when x is something like 3, 2x is 6, x is 3, and when you divide them, you get 2. And that's what happens for any value when x is 2. We have 4 and 2, which has a quotient of 2. Now it's true, it's not defined at 0. You get 0 over 0. But it's the 0 over 0 situation. The limit is going to be 2 because no matter which side I come from, this works for negatives also. We end up with 2. If I come here at like -5 or at -3, I get -3 is my x value, and -6 is the x value for the numerator, and -6 over -3 is +2. So the answer to this one was 2. And check this out. If you canceled out the x's, it would be the limit it would just be the horizontal line, y equals 2, or the limit of a constant function is always that number. So there's an example in our choices here. So we've seen all three of these happen. Okay, now look at this one. Limit of absolute value of x over x squared. And x is going to 0. Let me give you a moment to vote on this one. So it's absolute value of x over x squared. This is great. I could relaunch the poll just like that. Okay, so absolute value of x over x squared. What do you think of that one? Okay, there were 11 votes so far. Okay, so I'll end the poll. And you can see here that, by the way, this just because this is red doesn't mean it's the answer. I needed to, 0 is not the answer, but seven people said 0, 6 people said infinity, 1 person said undefined, 2 people said something else. Let's take a look at the graph. So what I have here, the red is the absolute value of x, and the blue is x squared. And when you take the quotient of those, you see what happens. You end up with like a sort of like a hyperbola, but this branch, instead of having a branch down here, the absolute value makes it go up there. And that's why the answer to this question was infinity. Because whether I'm going from the left or the right, this green is going way up high like that. So this one, the answer was infinity. Now, had I not had the absolute value, what would happen is that this kind of like reduces to 1 over x. And 1 over x is our basic hyperbola with a branch here and a branch here. But you see, for this one, the answer would be undefined because from the left and the right has different limits. But if I were to say limit as x approaches 0 from the positive side of 1 over x, that would be positive infinity. And if I said up here, limit as x approaches 0 from the left of 1 over x, that would be negative infinity. If I don't write anything there, I just say limit as it approaches 0, it's going to be undefined because the left and right are different. But I didn't do either of those. I threw an absolute value around the numerator, and then it actually did have an answer, because even though I don't have a plus or a minus here, they have the same answer, because from the left or the right, they both go up to positive infinity. So having the graph is definitely useful for that one. Sometimes we don't have the graph, but I'm going to now show you some really important questions. They may not look that important. They might just look like crazy questions, like who would ever imagine a graph like this? But you're going to see tomorrow that this type of equation is going to appear a lot. Now, this is an equation where if you put 0 in, then the numerator would become 3 plus 0 squared, which is 9, minus 3 squared, which is 0, and the denominator would also become 0. So this is one of those 0 over 0 situations. Anyone have an idea of how we deal with this one? Like which is the answer? What's the answer? Is it 0? Is it infinity? Is it 1? We've seen that it could become almost anything, but this actually does have an answer. Anyone have a thought of how we can deal with this? We can't just plug in, and we really don't want to graph this thing. You could plug in something close to 0, and maybe you'll get an answer close to something. Let's say you put in 0.1, and you got 6.1 as your answer. Would that mean the answer is 6? Or maybe it's trying to get down to 6.03 or something. But yeah, plugging in 0.1 would get you close. But here is the official way to do this question. You expand it. Now you might say, well, what does that do? Well, the 3's cancel out. This is a 9. That should be an x squared. Thank you. The 9's cancel out also. And we get 6x plus x squared over x. Well, that's still a 0 over 0 situation. And by the way, I wrote equals, but I really should write equals lim x goes to 0. Yes, and Zachary wrote, we can go further. Even though we can't plug 0 in now, we can factor an x out of the numerator. Then we can cancel out the x. And that is something we can plug 0 into. And 6 is the answer in that case. So this exact equation is going to appear in tomorrow's really important lesson. By the way, tomorrow, because I'm not going to be, I have to go somewhere and I'm not going to be here for the 10th period, I'll be doing the 9th period. Now, at least half the people in here are 9th period students. Are there any 10th period people who aren't going to be able, people who usually come 10th period that aren't going to be able to make it 9th period tomorrow? Okay, so some of the regulars won't be able to be there tomorrow. Okay, hopefully the 9th period, there'll be a bunch of 9th period people who haven't been able to come 10th period that will get the opportunity. Sorry about that. Okay, there's more scenarios coming. Oh, now look at this graph, and now I'm actually able to come to this thing. If I change this, hold on a second. If I change this to x squared, good. So take a look over here. This is the situation where the red is the 3 plus x squared minus 3 squared, and the blue is just 3 plus x minus x, which is 3 plus x minus 3, which is just x, and the green is the quotient. And you can see that quotient is a line. And as you can see, even though there's a nice hole there, that hole is located. See how it disappears when I get near it? When I get to x equals 0, the green disappears because undefined, because the denominator is 0. But we can see that its location is at 6, or would be at 6 if I filled it in, even though it disappears. I like that. Okay, let's take a look at got a few more examples like this. And yes, someone asked about tomorrow's meeting. I will post the video from that. Okay, what happens if I switch? The only difference here is that the exponent is a 3. Everyone take a few minutes to ponder what do you think the answer to this question is, and you could chat about it. Okay, so if you take a look, I expanded the 3 plus x cubed. I did a little binomial expansion. It's a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. The 3 cubes canceled out, and these terms all have x's in them. And when I factor and cancel the x, I get this. And now when I plug 0 in, I just get 27 as the answer. And you can see, not that this graph is not terribly useful, but in case you were wondering, this is what it would look like. Notice how the denominator is always x. Now this one, the red one, is a pretty steep curve, and the quotient became this green parabola thing, and it has a hole there at 0.27. Okay, now this next scenario, you'll notice that the denominator is always 3 plus x minus 3 for some reason. You'll see tomorrow why this type of equation is going to sort of appear in important questions. But for now, it's just, this is what the question is. And you're wondering, why not just call the denominator x if why 3 plus x minus 3? Well, we'll see that tomorrow. Look at this question now. Here is yet another one where if you put 0 in for both of the x's, you get 1/3 minus 1/3 is 0, and 3 plus 0 minus 3 would also be 0. But this does have an answer. Why don't you take a few minutes to mess around? How do you think you might deal with this one? You can chat about it. How are you going to get your foot in the door on this question? What are you going to start with? What's the first step that's important here? And yes, that's right, combining them with common denominator. Now this looks like it may not work out, but it is going to work out in the end. So go ahead and I'll work on it also. Okay, so I got to this point, and by the way, it's too bad there's not a shorthand for this, but these limits don't equal these other things, but they equal other limits. So the x's did end up, this x cancels out with that x, but I still have a lot of stuff left over. What happens when I put 0 in for x at this point? And that is the answer, -1/9. So what we've seen is, we've seen squared, cubes, and fractions. Here's a picture. This picture is not that useful as far as like, nobody ever really looks at this kind of picture to analyze a question like this, but I did want to show you that the numerator is the red hyperbola looking thing, and the denominator is just the blue y equals x line. And when you divide them, you can see how the green is also some kind of hyperbola. It's a hyperbola that is undefined at 0, but to the left and to the right of that 0, it seems to be heading towards, or coming from the left or from the right, it's heading towards the number -1/9. You may have noticed that so far, every expression we've seen so far has had this form, f of 3 plus x minus f of 3 over 3 plus x minus 3. This is starting with the time where, like for the first question, f of x was x squared. For the second question, f of x was x cubed. For the third question, f of x was 1 over x. These are the certain types. There's only really 2 more questions. And the fourth one is, what if my function was the square root of x? That looks like this. Now, this is yet another situation where if you plug 0 in for x, you would get square root of 3 minus square root of 3 in the denominator, and 3 minus 3 in the numerator, and 3 minus 3 in the denominator, and you would get 0 over 0 again. This one's pretty rough. Unlike before where we just combined fractions, you can't combine this numerator. There's no easy way to put those two things together. Why don't I give the whole class a couple of minutes to like ponder this, any ideas of how you might make progress. You can do this as something to start with. It's sort of the numerator that's the problem. Why don't you guys think about that and type some ideas into the chat? Okay, and I see that thrown out into the chat from Leo, the idea of the conjugate came up. Now, you might remember rationalizing the denominator from in Algebra 2. Well, maybe it's possible to rationalize the numerator. And if it is possible, is it going to get us anywhere? Well, let's see what happens. The denominator becomes x times radical 3 plus x plus radical 3. Well, that denominator got pretty ugly. What does the numerator become? Someone type that into the chat. When you do, you have kind of like an a minus b, a plus b thing going on here. So what's the numerator? What happens when you multiply something like a minus b times a plus b? That's right. Those people who wrote x, that is what the numerator becomes, because a minus b times a plus b is a squared minus b squared. So this becomes 3 plus x minus 3, which is x. And that x cancels out with this x. And now we have a constant in the numerator. Now we can plug 0 into the denominator and get 1 over radical 3 plus radical 3, which is 1 over 2 radical 3. And that's the answer to that question. We can see this, and I've actually shared in the homework assignment, I've shared this with you. You could just change this, just change the sort of root, the base function. So if I change it to square root of x, anyway, this is, oops. If I come over here, so you can see the red divided by the blue. It does get undefined when the blue hits 0, but you can see that that point is really close to that 1 over 2 radical 3. Okay, now there's only one more question for today, but it's going to need a little bit. It's not just going to be an algebraic trick. So far, we've done these algebra tricks to evaluate these limits. But for this last question, and the last question is going to be this, which is a mouthful because it's got sine in there. And it's not 3 anymore. I made it sine pi over 6 plus x minus sine pi over 6 over pi over 6 plus x minus pi over 6. So you could write down that question. But the last 7 minutes, I have to give you some background material for this. We could get started on it, though. We're going to hit a roadblock. You know, how do you think you can deal with this numerator? It's got a lot going on there. Denominator is really easy. There, denominators, that's fine. It's the numerator that's the problem. And that's right. Riley says the addition formula. So it's sine A cosine B plus cosine A sine B well, it's good, and that is the first step. But we're stuck here because if you plug 0 in for x, you will get in the numerator, cosine 0 is 1, so you'll get, and sine 0 is 0, so you'll end up with sine pi over 6 minus sine pi over 6, which is 0 in the numerator and 0 in the denominator. So this is the correct first step, but we're stuck because there are two facts that I'm going to tell you, and these are really surprising. Oops. Okay, here comes some facts. And good news, we're not going to prove these facts. We're just going to get an informal feel for them. Sine x over x. Now, sine x over x, that's a 0 over 0 situation. So what's the answer? Well, if we go over to the graphing calculator, I think I need, actually rather than the graphing calculator, I'm going to go back to the iPad. It's like I graphed these already. Okay, sine x and x, and this is, by the way, with x's in radians. Here's a graph. Then this one is pretty instructive. So you see how the red and the blue are they almost are right coinciding with each other when we're close to 0. That's why sine x over x, see this point right here at the peak of that green? That's undefined. However, the limit appears to be 1. And it is true, and I saw Zachary wrote that sine x is approximately equal to x for x is close to 0. And it's in radians. If you put your calculator into radian mode and type, sine of 0.00001, you'll get 0.00001. So this will be a fact that we will memorize. Though next year in calculus, you will spend a full day proving that identity. Probably a full day, maybe 2 days, but probably it won't be a half a day. It will be a full day proving this fact, rigorously. So let's keep this in our back pockets. We might need it for later. Okay, here's a second fact. Cosine x minus 1, well, cosine of 0 equals 1. So this is another situation where it's 0 over 0. And you might suspect that the answer is also a 1. But it isn't. And I'm going to give an informal graph. On the red is cosine x minus 1. Cosine curve shifted down by 1. The blue, of course, is just x. And the green is what happens when I take the quotient. And in this case, you see that green thing. That green thing seems to pass through the origin, even though the green thing is undefined at 0. And that's why the answer, that's sort of an informal reason why the limit as x approaches 0 of cosine x minus 1 over x is not 1, but it is 0. So this fact and this fact are just two facts we have in our back pocket so that we can continue with this question. Now take a look at this. I can do something very slick here. I'll put the cosine pi over 6 sine x here. And here I'll put the other, so that was that term. The other two terms I'll put these. Notice how they both have a sign pi over 6? That's convenient. What we can see here, oops, is this thing and this thing. Those were the two questions from before. So we have those in our back pocket. So what's the answer to this question? Okay, and that's right. Because this thing becomes 1, the sine x, the limit is that this, I'm going to put parentheses around the whole thing. Otherwise, I need to write a limit here also. So the sine x over x is basically 1. And the cosine x minus 1 over x basically is 0. So this goes all out. And after this is all done, all we're left with is cosine pi over 6, which is radical 3 over 2. Okay, and that's what I wanted to show you for today. What we've seen today are a bunch of different limits that have that seem to become 0 over 0, but by analyzing them, we're able to actually get answers to them. The fifth one was f of x equals sine x. Although we didn't use the number 3 when it was sine x, we used pi over 6. Maybe I should just call this A. Okay, so that's what I wanted to show you. Oh, I see a question here. What happens when it goes to something else? Well, if it goes to something else, you usually don't get a 0 over 0 situation. But we could create a question where we say that like the limit is x goes to 5, and we have like x squared minus 25 over x minus 5. So we could have other situations that seem to go to 0 over 0. Next year they will go. I mean, I'll like for this one, you would factor out x minus 5, x plus 5 over x minus 5, cancel out the x minus 5s, and then you could plug 5 in to get 10. So there's like little tricks for other situations. But for our purposes today, I hope you have understood how to do the different cases. I think I'm going to throw into the homework a question about cosine. Interested about what if it was cosine pi over 6 plus x minus cosine of pi over 6 over pi over 6 plus x minus pi over 6. You'd have to use that stuff again probably, but you would get a different answer. Okay, does anyone have any other any questions? Sorry that a lot of you who have been here every day, 10th period, aren't able to come tomorrow, but I will put up a video for that.